All right, so this is 2022 practice competition 2. We're going to take a look at 16 through 20. Now, a little preface here. I have not read these problems before, so if I'm a little herky-jerky with this explanation, that's why. All right, so what is the least possible positive integer value such that n is a perfect square, such that the square root of 18 times n times 34 is an integer. All right, so this is a matter of prime factorization. For something to be a perfect square, you need to have an even number of each of the individual factors that go into the numbers. So, prime factorization, here we go. 18, well, it can be broken into 9 and 2. 2 is a prime, and that's 3 and 3. So 18 is 2 times 3 squared. Now 3 squared is a perfect square. 2 is not, obviously. So then we have 34. 34 can be broken into 2 times 17. So we already have 1 2. Now we have a second 2, so that means we have 2 squared. And 17 is a prime. I can't do anything with that. So the only number in the prime factorization that's inside the square root symbol is 17. So that means we need to have another 17 for us to have a perfect square. Therefore, n is equal to 17. All right, well, that's a good start. Almost like I planned it. All right, 4 straight lines intersect a circular region. So before I do anything else, I'm going to draw a circle. There we go. Get rid of that little tail. Okay, so we have a circle. We have 4 lines, and the lines intersect. Okay, the lines in the circle are coplanar. That simply means that they're flat. So like the lines, if it's not coplanar, then the lines could be above the circle, or the lines themselves could not be on the same level, and so they wouldn't intersect at all. So that's why they have to say coplanar. Two of the lines are parallel. What is the maximum number of non-overlapping regions inside the circle? So right away, I can go ahead and give myself some parallel lines, because parallel lines are not going to be allowed to intersect whatsoever. So there we go, parallel lines. And so we need 2 lines that are not parallel that are going to intersect. So the first line doesn't really matter. I can draw it anywhere, so I'll just draw a line through the circle. Now my other line, I've got to, all right, so I have a couple options. I can have them intersect, it's purple, I can have them intersect outside of the parallel lines. So let's see how many regions that gives me. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. That gives me 10 total regions. All right. So, or I could try to have them intersect inside the parallel lines. Let's see what happens with that. So I'm going to do a little undoing here. All right. So let's say my last line goes through here. Let's see how many sections we get here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the question is asking us how many sections. So it doesn't really matter where the 2 non-parallel lines intersect. It's going to be 10. We're going to have 10 sections, and lo and behold, that is the correct answer. All right, so moving on. What is the base 5 product of the numbers 121 base 5 times 11 base 5? All right, so there are 2 ways we can do this. The first way is we can multiply them in base 5. All right. Well, let's see what happens if we do that, shall we? Or the other option is we can turn it into base 10 and then multiply it that way and then combine it. But that that tells me that that tells me that there's got to be a faster way, because two conversions, then a multiplication, then a third conversion, that seems like it's going to take more time than these problems are really allotted. So really, I want to look at a base 5 multiplication. So the trick with base 5 multiplication is every time we get a number that is larger than 5, that's 5 or larger, that's going to send an additional value, one place value to the left. So that's one thing we need to meet. But I'm noticing right now that we have 1s and 2s. I don't think we're going to get that situation. So I think we're just going to be able to multiply it straight and just be happy. All right, so we're now multiplying. 1 times 1 is 1. 1 times 2 is 2. 1 times 1 is 1. Well, we still have to have place values in effect for base 5. None of these numbers are 5 or larger, so we're good so far. And then, obviously, same thing happens. So now when we add these together, we can't have a number that is 5 or more, otherwise we're golden. 1, 3, 3, 1. And lo and behold, we don't get any numbers that are larger than 5, or 5 or larger, so the answer is really 1, 3, 3, 1, base 5. That looked a lot harder than it actually was. Oops, wrong direction. All right, these problems are not as bad as I was envisioning. Sometimes they can get gnarly. All right, here we go. Kyle's science project, this is a lot of reading, has 2 parts. The oral presentation is worth 30, so oral is 30. And the written section is worth 70. Kyle earned an 84% of the possible points for his written report. So we got an 84%. And then to earn at least an 87 of the possible points for the entire project, what percent does he need to get for the oral presentation for him to earn? Okay, so right now we know that, well, let's multiply 70 times, what's it called, 84 or 0.84. So I'm going to put the 7 here, I'm going to add a 0, or I can just put it here and put the 0 here. So 7 times 4 is 8, carry the 2, 7 times 8 is 56, plus 2 is 58. So that means, and we have 2 decimal places here, so that means right now Kyle has a 55.8 of the total points possible. And we are trying to figure out what score he needs to get all the way up to a 87 just by having a fantastic oral presentation. But not just the percent, not just the number, we want to know the percent. Yikes. All right, so it's going to be really close to 100%. So we need to add, so we have 80, we want an 87. Right now we have a 58.8. So what do we have remaining? So that's 2, that's 7, I'm just doing subtraction, 8, and that's, so that means he needs to get 28.2%, or sorry, 28.2 out of 30. That's, he needs to do real well on that. All right, so let's find the percentage, right? So, so we have 28.2 dividing by 30. All right, so how many times does 30 go into 282? Well, obviously it's going to be a 9, so that's 27. All right, so we end up with 8. So put the 0, bring it down, 8. All right, how many? Oh, geez, that's a 2. My God. This is why you don't do math late Friday after work. All right, so when we subtract it, we get 20. Bring that down. Rewrite that. So we have 2, bring down the 0. So we have 20. Well, obviously 30 doesn't go into 20, so. Oh my God, I'm having troubles. I should just subtract. Okay, so 2, so 0 minus 2 minus 0 is 2. 8 minus 7 is 1, 2 minus 2 is 0. Okay, so we get 12, remainder, bring the 0 down. How many times does 30 go into 112? Well, it's 4, right? And so that means he needs to get a 94% on his oral presentation. And that is the correct answer. Look at that. Will wonders ever cease? Sorry about my subtracting error. I swear I teach math for a living. All right, a chain with 2 links is 13 centimeters long. Come on, hello. A chain made from 3 links of the same type is 18 centimeters long. How many centimeters in length will a chain of 25 such links? Okay, so right now, 2 links is 13. I'm going to write this down a little ratio here. And then we have 3 links is 18. All right, so how much is each link? Well, that's a good question. Well, we want to go all the way to 25 links. So, how are we going to do this? Well, the one thing that I could do well, we know that this way, that 5. All right, so I did a little looking and thinking here, and I realized, well, here's why I was struggling a little bit. This is a difference of 5, right? But obviously, 13 minus 5 is not 5, right? So that means that first link, this is not a linear progression. That first link has to be 8 because 13 minus 5 is 8. So that means if we have 25 links, that the first link is going to be 8. And then every additional link is going to be 5. Well, how many groups of 5 do we have if one of the 25 is 8? Well, we have 24. And that's going to do it here. So 5 times 24 is going to be 120, I believe. Yep, plus 8. That gives me a total of 128. Now, is that the right answer? Oh, yeah, look at that. All right, so for number 15, that's on the next page. All right, nothing's more fun than watching a teacher scroll through problems on a YouTube video. That's why most people go onto YouTube. All right, Kevin's order of 2 hamburgers and 3 sodas. I'm gonna write this down. 2 hamburgers plus 3 sodas costs $10.30 at the burger spot. Alana orders 4 cheeseburgers. Uh-oh. We have hamburgers and cheeseburgers, so I'm not going to write this directly underneath. I'm going to give myself a different color also. That's not the different color. All right, so she orders 4 cheeseburgers and 6 sodas. Oh, that's going to be helpful. Because now it's 6, okay, maybe not. And the cheeseburgers cost 15 more cents than a hamburger. All right. So that means that cheeseburger is equal to hamburger plus 0.15. All right, so I'm going to sneeze here. Excuse me. All right, so Alana orders 4. She orders 4 hamburgers. Okay, so really, she's ordering 4 hamburgers plus 6 sodas, and then we're going to tack on the 15 cents at the end. Okay, so I can't help but notice that 4 is twice of 2, 6 is twice of 3. Therefore, all we got to do is multiply this by 2 and then add on 60 cents. That's 4 groups of 15 to get the cost of the cheese that's put on the cheeseburger. All right, so I multiply this by 2 and I get $20.60, but then I have to add the 60 cents for the cheese, and I get 21 And so that's a 0, that's a 2, carry the 1, yeah. There we go. So 21, 2, 0. Oh yeah. Hey, as a bonus, you know what we're gonna do? We're gonna do number 14. I feel like I'm on a roll.
So fun.
I know, I'm having fun here. Having so much fun, I just don't want to go home. All right, I can give myself a little more room. All right, so we see half the sphere circular base. The surface area of a sphere with a radius r is, so the surface area of a sphere, so surface area, we need to know the surface area equation. So surface area of a sphere is equal to 4 pi r squared, I believe. All right. And so the surface area of the sphere, oh, it tells us there. Oh, I remembered it. That's nice. Okay, including the area of the circular base. What is the total surface area of the hemisphere with a radius of 6? Oh, that's not bad at all. So all we have to do is find half of the surface area of the sphere, because we have a hemisphere, and then add the circular base on top of it. No big deal. All right. So we have 4 times pi, and it gives us our answer in terms of pi. We don't even need to multiply by 3.14. I love it. So we get 6 squared. So 6 squared is 36. 36 times 4 is going to be 144. And we still have our pi. But remember, we only want half of it. This is the full sphere. So half of 144 is going to be 72. Anya's not paying attention.
Huh?
So, just proving me right. So 72. Now we also need the area of the circular base. And so a circle is pi, the area r squared. We have pi times 6 squared. 6 squared is 36. So we have 36 pi. Add this to the 72 pi. So pi is just pi. And then so we have 8, nothing to carry. And we have 10. So this is 108 pi. Oh, yes. Look at that. We're flying through this. All right. You know what? Let's try number 13. A pair of 6-sided dice is rolled and the sum is recorded. What is the probability that the sum is a multiple of 3? All right. So the easiest way to do this one, this is a good one, because we can relearn about area models.
What about area models?
We're going to do this using an area model. So
Fun.
I know, it's super fun. So 1, 2, 3, 4, 5, and 6. All of these are possible outcomes for our first die to roll. Well, what are my possible outcomes of my second die? So this is when things fall apart, because I was really hoping this was audience participation time. What are my possible outcomes for my second roll?
1, 2, 3, 4, 5, and 6.
So each square represents one possible outcome, which means we have 36 possible outcomes. And we just need to figure out which one of these outcomes is divisible by 3. All right, and it's the sum. What is the probability that the sum is a multiple of 3? So 3, 6, 9, 12. All right, so we have 3 here, which also is 3 here. 5 plus 1 is 6. 4 plus 2 is 6, 6, 6, 6. All right, I'm just going to differentiate between the rolls and the numbers. All right, and then, well, 3 plus 6. 3 plus 6 is 9, so we get a 9. 5 plus 4 is 9. 5 plus 4 again is a 9. And then 6 plus 3 is 9. And then we have a 12 way down here. All right, so out of the 36 options, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 out of 36, which is a grand total of 1/3. Now that should have been obvious to me, but it wasn't. Why would it be obvious, should you say? Well, because we have, on each die, we have 2 out of 6, and 2 out of 6 would be equal to 1/3. So we didn't even need to make the area model. Look at that. All right, we'll do one more and then we're done. We are done. I want to go home. All right. Okay, maybe 2. All right. Marina's annual salary is a whole number of dollars, so no sense, between 42,400 and 42,500. The digits in her hundreds, tens, and units places are strictly ascending in order. How many distinct possibilities exist for her annual salary? The digits, okay, so the last 3 digits are ascending. So it doesn't mean that they have to follow a pattern. So that means we could have 4, 5, 6, 4, 6. Oh, sorry. We should have all the possibilities with 5, right? So 4, 5, 7, 4, 5, 8, 4, 5, 9. All right, we could also have 4, 6, 7, 4, 6, 8, 4, 6, 9, 4, 7, 8, 4, 7, 9, and 4, 8, 9. All right, so how many possibilities? 4 plus 3 plus 2 plus 1 is 10.
Yay!
All right, so we'll do one more because we love factors. This competition had a lot of factoring problems. Not factoring like the quadratic sense of the word, but like factoring as in prime factorization. All right, so number 11. How many positive integer factors of 2 to the second times 3 to the second times 5 are multiples of 12? All right, so here's the thing. A multiple of 12, so if we're looking at 12 in prime factorization is 2 squared times 3. So we need to figure out how many different ways we can have 2 squared times 3. This is what we're really looking for. So, all right, so we have 2 squared, I'm just writing all right, so we can have 2 squared. Right, so we have to use these 2's. So we could have 2 squared times 3, 2 squared times 3 squared, 2 squared times 5 times 3, because we have to have the 3 and the 2 squared. And we could also have 2 squared times 3 squared times 5. So that's 1, 2, 3, 4 options. And double check. Oh yeah, 10 for 10.
Yay!
It makes me feel good. I hope you guys have a great long weekend.